Yeah, thank you, Bernd. Thanks for having me here. My name is Sebastian Schubert. I'm a solutions engineer with Grafana Labs. I'm on the pre-sales part, so I'm the one that usually nags you before you buy something from Grafana. And today I'm here to talk about our open source solutions that we also have. We don't have only enterprise products, but a lot of the stuff that we have is open source, and all our enterprise stuff is based on that open source. And I'm just going to show you in roughly 30 minutes what we think about how we can scale logs with our solution. And yeah, so let's get started. Who of you knows Grafana or has been using Grafana? So that's cool to see so many hands here around. Most of the folks use Grafana for a visualization use case. They have several data sources, and they usually just have some data sources that you just put on the dashboard. Grafana does a lot more than just produce something that shows you dashboards and time series and logs. We also produce the databases and the whole environment around that, where you can ship your logs and get all the data into a database that you then can query. Is it a time series database, or is a logging database, or a tracing database, whatever. We usually have an open source solution for that. And if you're a Grafana customer and you're using our cloud stack, you can get a lot more, but we're not going into a sales show today because we want to hear something about logs. So let's get started and talk about logs. Who've using a centralized logging solution already? Yeah. Is it based on something Lucene, like Elasticsearch or so? Yeah. Is it scaling? Okay, some say yes. I see some things. Okay, so just a short recap, why are logs important? When you think of modern monitoring or observability, you will think of metrics. I need some metrics, and this is something that I need to bring to my components. Like, I have to instrument them. Something that's usually always there are logs, because applications since the last 30 years, they just tend to emit logs that are meant for humans, or mostly for humans. And so every important action is usually logged into a text file or is exported via syslog or something like that. So logs are always just there. And with a lot of new technologies like microservices that are really chatty and IoT devices or things like that, they produce a whole lot more logs than when we see from traditional systems, because they're really chatty. And it's really, really important for most of our customers to collect and analyze those log data, because when you think of, like, you have a very small IoT device, you won't have a full-blown Prometheus stack running on that. You just have some logs that you want to send with some delay, because it's sitting near a cow herd on an Alp in the Bavarian Alps. You just want to emit that log, and it's not time critical. But you want to get some data out of it, so usually you just take a log and you don't do some over-engineering, like instrumenting it with tracing and things like that. This is something that we see in most of the IoT use cases. We have a lot of customers and we have a lot of open source adoption, so that's one of the things that is really good for us as a company. We can talk to a lot of people and we can ask them questions about, hey, what are your challenges when you deal with logs? What are your problems you're facing? What's your pain that you're trying to solve with logs? And the most things that we hear from our customers, prospects, users, is that most of the current existing logging and metrics technologies are really hard to operate at scale. And with scale, I say, I'm ingesting like a terabyte a day, or 5 terabytes a day, or a petabyte a day. These are regions most companies usually don't run into that. But if you want to run into such situations, because you have, like, Black Friday, for example, you usually don't have a very, very small amount of logs and metrics, but on occasional events like this, there will be huge spikes, and you want to be able to absorb them to get some data out of it or analyze that afterwards. Anyone of you here doing e-commerce or running e-commerce sites? Yeah, one of them. How's it with you? Do you see some things like that happen, spikes, and yes, I see one person nodding constantly, okay. So this is one of the third thing, that it's really hard to operate at scale. The second thing is that it's expensive to scale, because traditionally you need to buy some licenses for example, for the enterprise products that are out there. You need to buy expensive hardware, expensive drives, and the third thing that we hear, it doesn't really correlate well with anything that's outside that vendor stack. It's like a data silo. You put some data in, but you can't get any more value out of the data, and you can't just simply jump from a log to a metric to a trace and things like that, because all of that is somewhat siloed inside a vendor solution. That's why our CTO came up roughly 5.5 years ago and designed Loki. And the idea behind Loki is we designed that not for business users, not for SIEM use cases or things like that. We designed them for DevOps engineers to be effective at debugging and troubleshooting their applications. We designed it for the SRE folks that are out there to visualize and alert on service apps and performance metrics. And we built it for data engineers that will be able to build some actionable insights from the log data that you can take it out afterwards and generate some meaning out of it. And this is also something with the design goal of every technology or database that we are making. We have not only Loki for logs, we have Mimir for metrics, and Tempo for traces, and Pyroscope for profiles. And this is like most of that stuff applies to all the database that we're making. So how does Loki work? Any one of you already using Loki or running Loki at a production or test environment? I see a few hands. That's nice. You have, like in Star Wars, we saw that earlier today from Bernd with his Star Wars intro. We have the dark side and we have the light side, and so we have the ingestion side of data, and this is the ingestion side I'm showing you. You have components that are emitting data, like your application, your infrastructure. Maybe it's a card sitting in a server and emitting SNMP traps or whatever. You can take those data and ship it. And the shipping is usually done with a component that we call Grafana Alloy or Promptail. These are components that are able to get the data and push it to the Loki database. You can also use OpenTelemetry as a standard for sending data to Loki. I don't know if you've already adapted OpenTelemetry in your company or in your stacks or not, but we can also use that. Or you can just do a plain HTTP call and push data in via REST API, and you're just free to just ship the data. It's not that you need to create a schema before. You just go and send the data with some metadata attached to it, but it's not that complicated like other softwares where you need to create a complete definition of what data will arrive anytime soon, and you can send the data after that. You just push the data with those clients or directly via the API. You can then have Loki emit some metrics, for example, like you can do count how often did I receive a log file or a log line and things like that. We'll come back to that later. And you can use Grafana for getting insights into the data, having a look at how the data is sitting inside Loki, how to correlate the data, maybe have some data sources on a dashboard that you just chain together. And for the hardcore fans, you also have log CLI and the REST API, so you can use just curl to get the data back and then do your favorite pipe grab, pipe set, pipe AWK, whatever. This is not the usual or typical use case, but you could do that as well. Collection is really, really super easy because the ecosystem around Loki has evolved. In the beginning, we just had Promptail or REST API. Now most of the big log components that are out there are able to ship data directly to Loki. Like, for example, Logstash or FluentBit, FluentD, if you're still using it after the security nightmares earlier this month. Docker has a built-in capability of sending data to Loki. You could use AWS Lambda functions. It's really open and versatile, and you just can use it use any technology that's out there, even from competitors like Datadog. They have Vector. I don't know if you're using Vector. It's a really great tool. You can just take that client and send the log over to Loki instance. And the beauty of that is that you can automatically attach labels to your log line, so you can actually find the data quite easy and correlate it with the rest of your infrastructure metrics. I think earlier today we asked how many of you are running Kubernetes. I think it wasn't all of you, but most of you should be able to get the mental model that you're using when you're using labels like Kubernetes does. Everyone aware of how labels are being used in Kubernetes on Prometheus? Not so much interaction. I think most of the folks are just in the Suppenkoma, as we call it in Germany. Just after having a talk after the lunch is always great. So, back on Loki. What we do is we try to make logging at scale very, very efficient, because logging 5 megabytes of a Raspberry Pi log a day isn't a big thing, but if you're running big clusters and multiple terabytes of data per hour or per day, you need to have it really, really efficient and not say, okay, then I'll just add another 2 NVMe disks to get as many IOPS as needed, for example. For that, we've come up with a design that's not typical for most of the logging solutions. The data that you ingest will not be indexed. We just have some small index on the data, and this is really good when you look at the ratio that we're getting. Approximately 50 megabytes of index will be created every 10 terabytes of log data that you ingest. When you compare that to other solutions that are based on Apache Lucene, like Elastic or Graylog or things like that, you usually tend to have more than that. Like 10 terabytes of data will usually be 10 to 15 terabytes of index, for example, in worst case, if you index a lot. So our approach is different. It saves a lot of time when you just push the data into a system. You don't need too much compute resources, not too much RAM. You just can push the data in without using too much resources. You're not indexing too many data upfront. When you think of our indexing, it's more like when you use a table of contents. So the thing that you're looking for is somewhere between page 1 and 5, instead of the keyword that you're searching is actually on page blah, blah, blah of that book. So that's how we're doing that label matching into a small index that will be very efficient. Coming back to the question about the labels, you might be aware of the Prometheus data model that you emit metrics. You have a timestamp, you have a metric name, you have some labels, and you have a value. And we try to adopt that for Loki. We have a timestamp with a very high precision, so that's something that we needed, or we saw that we needed float 64 precision. We have some label selectors, and we have the actual value, the log line that you emit or that you send to it. And the left part of the equation, this is the stuff that will be indexed, and the content, this is the stuff that won't be indexed. This will just be written to an object store. And with the index, we know where we can search for the data. This will come a bit more clear if we take a look at, we're just sending data, for example. We have some labels applied, like this is the application card and the environment def. And all the data that has the same labels will be put together in one log stream, and that log stream is then saved as an object on disk, together with the timestamp information. And we have another log stream here with a difference. We have the environment set to prod, so this will go to another log stream. And if we search for something, we will just distinguish between, okay, which labels do match, and then just go brute force on all the data that's sitting on the object storage. How do we get the data out? Usually you write a query like that. You have that labels that we saw earlier. We have a label called frontend here, named frontend. We have that label matching. And then we have some filtering after that. And for example, if you would like to see, we have Icinga conferences from the last years, for example, and we want to know which talks Bernd was giving. And we're just gonna go, okay, we're gonna search all the logs that match the Icinga and do not match the logs, this is regex, from 2010, because we're not interested in that old stuff. And then we just go through the content, search for speaker equals Bernd, and maybe we exclude his welcome talks to see if he has done anything else than just welcoming the people. So we get back our data, and this is, if you're used to Unix systems, which I hope most of you are. Anyone not using Unix systems, please leave the room. No, just kidding. I've seen Windows now with Windows subsystem for Linux also becoming more of a Unix system. But the thing is that you're familiar with pipes, with taking output of one system and piping it to another, and that's how Loki actually works, where you get the data back. So we're gonna explore and query the data. First thing, before you write data, think about what you put into a label. There are things that are quite good to do, and there are things that are not so good to do, because it will become a very high cardinality when you, for example, with every log line, you index the timestamp that is coming, because that will become a big, like every second will become another log stream, which will be really hard to search for. Think of user IDs or trace IDs or anything like UU IDs that you put in. They're not great for labels, and just keep that in mind when you design your logging pipeline and what about to push into such a logging system, what to index and what not to index. Things that rarely change are really good, like a cluster or namespace, things like that. They're really good for labels, help you get your data back really fast. But other that are have high cardinality, they're usually not meant to be indexed in that way. I just give you one example of Grafana Cloud, which I'm not about to sell today. When you think of, and this is real use cases that we have from customers, they're just searching their data for the last month, have roughly 1 petabyte of logs. They just trim down the amount of data that they have to go through just by selecting the correct labels to 80 terabytes. This is one of the bigger European customer. Then we just narrow that down by, I want to see the last 7 days instead of the last 30 days. And this will then just be a real small result set of roughly a terabyte that we need to go through. And with our infrastructure that we run at AWS, we're capable of retrieving about something above 1 terabyte per second, a terabyte, not bit per second. Then we go per a brute force approach and just go through all the log data. Keep that in mind. If you want to run Loki yourselves, you need to have beefy disks and beefy network and object storage that is powering that if you run into that scale. But if you're running at that scale, you will probably almost have a real good fast storage and real good network between your nodes. How's data queried? Think of those log streams that I've told you before. This is log stream 1, 2, 3, 4, 5, 6, 7, 8. Those are all log streams. And they are just objects laying on an object storage. And you now come and say, hey, I want to see the data for this cluster and that time frame. Then we're going to just massively parallelize the queries, split them up, and have it, because Loki is horizontally scalable, we just spin up some more infrastructure and we'll parallelize all the data queries among those storage buckets that we defined for before, like the log streams that we've seen before. And so we can achieve really, really high throughput and low latency when it comes to displaying the data to customers. You can see that we usually run, for example, we have a query here for show me the last hour, and then we will split it up into 4 runs. The first 15 minutes, they will just immediately display, and after that, with something we call lazy loading, we're just gonna query another 15 minutes and so on, and just push the data to the UI in very short, with very short delays. But you will get instant feedback on your queries and get some data back instead of waiting for 2 minutes or whatever you're used to when you're acquiring data of that size. Okay. The trade-off that we made is for Grafana Loki. You see that we can take any log in any format because we don't need to know what data will be arriving. We don't care if you have a schema defined or not. You don't need that. You just send it. We have very small indexes, and that's why it makes it really cheap to run, because you're not consuming too much CPU, RAM resources. It is able to do fast queries, and you can cut and slice your logs in a dynamic ways because of that label model that you know it from Prometheus. Other logging solutions that do upfront processing, you usually need to decide on the log format. Think of you want to deploy a new application, and you can't do that because you need to define your logging pipeline before just being able to send some logs. You're really using larger indexes, and it's upfront, it's more expensive to run because you need to log all the data that comes in. And I don't know if you're taking any measurements, but usually 30% of the data you send in, you will query back, and 70% of the data you will most likely not ever look at again when it comes to logs. Don't know if you've seen similar numbers, but that's what we see with our customers. And yeah, that being said, just some use cases, because Chris mentioned it earlier in a short talk we had here. Do I need ad hoc metrics? Have you ever thought of going through your log lines and creating a metric out of that? Like, how many 500 errors from my web server have I gotten in the last 3 hours? Anyone ever been doing things like that? Yeah. With what solution did you do that? With Loki already, or with something else? I'm sorry? Grab sort unique, yes. It works, yeah, it's great, and it's we have a way to do that more efficient, we think. And for example, if you look at the web server log line and you're interested in, hey, I want to see the responses by path, for example, so I can narrow down where problems occur, and the status code, we were able to take that log line. This is just a raw Apache log, common log format. Take that and do some magic, or yeah, basically it's just a log query where you go over the logs, say, okay, I want to have that summarized by the path and the status code, and we then extract those fields like the path and the status code and the value from that line using some regex matching, and so we will be able to pull some information out of the data, generate metrics from you, regardless of the data has been indexed or a schema defined before. We could just analyze that, and this makes it really, really powerful to get insights into data that is really, if it's really unstructured. We have a lot of functions that you can use. These are just the basic ones that you might be using very, very often if you use Loki, like using different log formats like JSON or log-fmt from Go. We have filtering capabilities with regex, negative regex, greater, smaller. We can, for example, see if you want to see, in this case, I think it's latitude and longitude on the filter thing. If you want to search for geodata, this is all possible with Loki. And you can also reformat all the data that you put in and put it out in a completely other way, which is really nice if you want to redact data that you have some personal identified information in there that you just want to get rid of and not being displayed. I'm sorry? No. So the question was, can I use Grok? And thanks, Bernd. I think this was like the Jürgen Klopp of things like change it. I think we played. Grok rules are not supported, not yet, but it's open source. You can contribute if you want. But we think our query language is efficient enough that we don't use Grok rules. So you've done this calculation once and you want to do it over and over again. You think this is very efficient to run such a query very, very often. When you go through, like you want to see that on a monthly base for your web server logs, it's not very efficient because you have to go through a month data. So that's where recording metrics comes in, where you automatically use the log data and emit a metric from that log data and push it to a metrics database like Prometheus or Mimir, where you can just query the data back in a way more efficient way than going through 1 month of logs. And that's why those recording rules exist. And if you're familiar with Prometheus, there are also recording rules. It's basically the same with Loki. You can do the same and just need to write it to another system because Loki doesn't store metrics. Recording rules will help you make your queries way faster if it comes to showing data over a long time range. It also helps you make your dashboards more stable and scalable and happier users because you will get your data way, way faster than just going through the raw data. Short example, I think we're running short of time, but I think the other guys didn't take so long, so I have more time for me today. Oh, no, okay.
No, but yes.
No, but yes, okay. So think of someone querying the data. You do a recording rule from your original store and just write it to a metrics database. And you can then query the aggregated or pre-aggregated data from that recording rule. Any one of you familiar with materialized views from a database point of view? This is exactly the same for metrics. You could use the same for metrics with that materialized view thing. You can query the data, the new aggregated data, but if you want to get back to the raw data, you can still use the raw data because it's still there. So this is okay when you're doing it all alone, but if you're having many dashboard users, like the thundering herd that wants to see metrics at the first of the month, for example, then you would take those folks and just push them to the recorded rule data because they will get way faster results instead of going through the data themselves. And the thing is, why we implemented this because Loki is optimized for logs and not really for metrics. You can do metrics, you can do all of that, but if you want to get it fast, just use the metrics, and recording rules will really help you getting there. This is how it could look like for having such a statement that you define to go through all your logs. And this is like basically create a summary by method, and you go over some data, and you would define a recording rule in a Prometheus style. Recording rules or recorded metrics usually should follow the convention that you have a colon separating all of the meaningful parts of the name, and this is the recording rule that will actually do the same. It will execute that query every defined time, and when you query it afterwards, you're just gonna query the new recorded metric, and that's basically how you get a lot more speed when try to look over bigger ranges or time ranges. There's some do's and don'ts, and I think those slides will be published afterwards. You can go through them, but usually you use those recording rules with really expensive aggregations over bigger time ranges or very small label sets, and you use them when you have really high traffic dashboards that you use. You don't do that to reduce the number of labels of metrics or so. And you don't use it with aggregations that are rarely used because they're just execute them. It's not that expensive. To see how Loki could look like, I've brought this dashboard, and you can either scan a completely unknown QR code at a conference, which I usually don't do, but This dashboard is completely made out of logs. This is just a web server log that we took and applied all of the magic that Loki can do. So you can see, for example, status codes split up and things like where do the folks come from that are visiting my website displayed on a geomap. And this is all done by log lines. There's no metric or anything like that inside there. And if you want to see that, just go to our playground, playgrafana.com, and I will just have it on one of the next slides. As Bernd was doing some updates, I've sneaked in some update slides as well. For those of you who've been using Loki for some longer time, Loki's just turned 5.5 years now. We've improved a lot based on the feedback that we got from the community. We introduced the Prometheus time series database as a storage format internally, which sped up Loki a lot. We used completely new template functions in LogQL that makes you retrieving the logs and formatting them way better. And we also put something in that you can limit the queries that you can run on a cluster, so not everyone can do like select Stern or select asterisk from anything. We've built something that's called volume insights, where you can browse through your data, where you can see where's the log usage coming from. If you want to do some showback or chargeback based on, hey, there's a application A is sending 15 terabytes a month, we got to pay for that, so we got to get the money back from the folks that are sending the data. And with Loki 3.0 that just landed, we have introduced native OpenTelemetry support, so we can just send everything in OpenTelemetry protocol. And we supported experimental Bloom filters, which will revolutionize the whole retrieval. Any one of you aware of what Bloom filters are or how they work? Yeah. Bloom filters will help you to say where data is not, and we can then exclude big chunks of data, just don't go through them. They will say there might be data in this data chunk, you have to look at it, and this will also speed up because we don't need to retrieve that much data from disk. And this will be really, really blazingly fast. From the Grafana side, Grafana integrates very deeply with Loki. We've introduced a table view like you're used from other logging tools, where you can go through your log lines and just click the labels that you have and see that data based on those filters that you just applied. And if you want to see Loki in action, please try it yourself. Follow this big QR code, and by overrunning by just 5 minutes, you can ask me anything after the talk. You can get some stickers. I have a bunch of stickers with me. And I don't know, Bernd, how much long can we take for Q&A? Or
now we have 5 minutes over. If we have 1 or 2 questions, we can take it. And Martin, the next speaker, will get the time as well. So
okay.
If we have 1 or 2 questions, we can take them.
Bless you.
Are there any questions? Don't be shy. If it's not upstairs, then I have to run. Okay, wait, I come over. No, stop it. Please.
You just wanted to have the QR code? I hope it's...
Here's the QR code.
We can dance the QR code for you if you like.
We can dance it out. For every pixel, one move. Text noise. So yeah. Any question? Okay, in the back. So we do that. Let's say first or last question, depending on the perspective.
So, question about the Bloom filters. If it's not the label data you're filtering, you have to get it from the storage. Otherwise, you cannot filter it. Or is there a misunderstanding on my side?
No, there's we use a combination with Bloom filters and n-grams. We use n-grams. You're aware of n-grams?
No.
We have an excellent blog post that just came out that explains all of that. We just do tuples of 3, I think it is 3 characters that we define as n-gram in the context. and then we're just going to search on that and put them in the Bloom filter. If you're interested, I can show you afterwards, because I think most of the people will not see that. But if you want to see that, just come approach me, and I'm just going to show it to you. Okay?
Thanks.
Okay. With that, I would say, Sebastian, thank you very much for the fantastic talk. Thank you.